In this video lecture, we are going to see the Java virtual machine, which is called JVM. The compilation and execution of a Java program is not like the compilation and execution of a C program. In a C program, when we compile it, what happens is directly the machine code is generated. So, whereas in Java, when we compile the Java program, the machine code is not directly generated, but a byte code is generated. This byte code is called intermediate code. Then this JVM, Java Virtual Machine, takes this byte code and interprets it. So the JVM executes the Java byte code. Here in JVM, Java Virtual Machine, we have different components. Now in this lecture, we are going to see the three different components of Java Virtual Machine.
Java Virtual Machine JVM. We know that Java is both a compiled and an interpreted language, and the Java source code is first compiled into a byte code. This is what we studied when we looked at the features of Java. See, the program Java program prog.java is first compiled by using a compiler. Now what happens? The byte code is generated, which is also called as an intermediate code. Then this byte code has the extension dot class. That's why it is called a dot class file. This is dot java or program. Then after compilation, dot class file is generated. Now this dot class file is given to the JVM. This is JVM, Java Virtual Machine. Now this Java Virtual Machine interprets the byte code and it generates the machine code so that our computer or the processor may execute the code. Now the Java interpreter generates machine code from the byte code. So this is the work of the JVM. What is the work? The JVM's work is to take the byte code as input and generates the machine code. Now I wrote a program hello.java. Then I saved my program in F drive my programs folder. Now I'm going to this F drive CD my programs folder. Now I'm typing this. I typed this command DOS command which is called dir. It shows all the files which are there in our directory. Now in my F drive and my programs there is only one file called hello.java. Now I compile this file javac hello.java. This is for compilation. Now then after compilation once again I typed this dir command. Dir is for what? It is to display all the files in our directory. Now what happens after compiling the Java file? We can see that there are two files here, right? Already hello.java it was there, and newly hello.class file is created. What is this dot class file? This is what we are talking about, the byte code, right? After compilation, java c for compilation, after compilation then what happens? This dot class file is created. In this way we can see that this is the source code hello.java and this is the dot class file which is byte code. Now when we run the program we give this dot class file to the Java virtual machine. Now here this is also we studied in Java features. Java is platform independent. What does it mean? It means a program compiled on one machine can be executed on any other machine. Yes, one machine. Here machine in the sense one computer. You can say that one processor. The program which is compiled in one computer can be executed in any other computer. Then how is it possible? It is possible because of bytecode. Bytecode is designed to be executed by the Java runtime system, which is called JVM. That's what we saw here. JVM executes the bytecode. It interprets the bytecode. Now the bytecode is machine independent. That means it does not depend on which machine it is going to be run. Then finally, portable. Portability means the ability to move the program from one computer to another computer. Anywhere and anytime we can run the program. How is it possible? Once again, through the bytecode. Write once, run anywhere principle. It follows, the Java follows. Now, if you see this diagram also we saw in the previous classes, here test.java. This is our Java file. Then when we give it to the compiler, test.class file is generated. See, this is what happens. Java file, then .class file is generated. And this .class file is given to the Java virtual machine. Then you might have observed here one system with Windows operating system, another computer with Linux OS, and some other computer with Solaris OS. Then these three different computers have different JVMs: Windows Java virtual machine, Linux JVM, and Solaris JVM. Now this bytecode is given to Windows JVM, and that bytecode can be executed by a computer with Windows operating system. Similarly, different operating systems, they come with different JVMs. Remember, JVM is here, it is machine dependent, machine specific. This Windows JVM works with Windows operating system only. Anyway, .class file is generated, and this .class file is executed by this JVM. Now, what are the duties of JVM? So these three are the important duties of JVM. Then what happens is our .class file. Our .class file is actually loaded into the RAM. We know RAM means the random access memory. .class file is loaded into the RAM. Then it verifies the code, whether it is following the standards or not. It verifies the code. Then after verification, it starts executing the code. So these are the three important duties of Java virtual machine. Now here we can see that in Java virtual machine we have three different components. One is class loader, second one is runtime data area, which is sometimes called memory area, and the third component is execution engine. This is JVM. Here it is JVM, and this JVM is loaded in the main memory RAM. Then here, if you see, the first we consider the class loader, then we will see runtime data area, and finally execution engine. If you see the class loader, this is a very important component where it loads the .class file into the main memory. Remember, if a computer executes anything, I mean the program, it must be first loaded into the main memory. Now here it has three components. One is bootstrap class loader, then extension class loader, application class loader. With this bootstrap class loader, it loads the rt.jar file. This is rt.jar file, runtime.java archive, rt.jar file, where the java.lang and some other packages are there. Then this extension class loader, then it executes some other jar files from JRE and lib folder, ext folder. You can see it in the Java installation. And finally, this application class loader loads our .class files. And at the same time, this class loader also verifies the code. Now, first loading takes place. Then runtime area. Here runtime area has different components. One is the method area, where some class level data is actually stored here, some static variables, where these are called class variables. Then heap. Here, from here, the memory is allocated to objects. All the instance variables are stored in heap. Then all the local variables are stored in stack. PC, program counter, it stores the address of the next instruction. And finally, native methods means the methods which are written in C and C++. So it allocates memory. So the work of this runtime data area is just for allocation of memory. And finally, execution engine. This is where the bytecode actually gets executed. So that's what we are writing here. It is an important component. Execution engine is an important component which converts the bytecode into machine code and it executes the machine code. Here we have three components or three parts. One is the interpreter, the main one, which reads the bytecode and executes it. So we know that class loader loads the class into the main memory and it allocates the memory for all the variables. And then finally, this execution engine starts executing the bytecode. Then there is something called JIT compiler. JIT means just in time compiler, which is useful when a method is called repeatedly. For example, in the interpreter, if we call three methods or if we call the same method three times, then the three times the bytecode gets executed, converted into the machine code. Whereas if we use this JIT compiler, what happens is that method which is called repeatedly, right, that for that method it will generate the native code or machine code. It executes the machine code, so it works a little bit faster. Then finally, the garbage collector, which destroys all the objects which are no longer used. Now these are the three important components of JVM. The JVM's work is to take the input of the bytecode and executes the bytecode in the particular machine. Thank you.